Hi, welcome to Nomis Academy. In this video, we are going to be looking at tangent theorem, and we are going to consider theorem 2. In the previous video, we explained theorem 1, we solved problem, and then here in this video, we are going to be looking at theorem 2. Okay, let's take the theorem. It says that when two tangents are drawn from an external point P outside the cycle, then have two conditions. The first condition is that the tangents are equal. And then the second condition is that a straight line drawn from O, the center of the cycle, to point P bisects the angles between the radii and the tangents. Okay, so this is the theorem. It says that when two tangents are drawn from an external point P outside the cycle, then the tangents are equal. That's the first condition. And then the second condition, a straight line drawn from O, the center of the cycle, to point P bisect the angles between the radii and the tangent. Okay, let's take a diagram to clearly see what the theorem is talking about. Let's take the diagram. We have a cycle here, and then we have two tangents from external point P. Okay, they meet at this point. Here is the center of the cycle. Okay, of course we know that the tangent is always perpendicular to the radius of the cycle. Now the second condition is saying that if a straight line is drawn from center O to P, then it bisects the radii. The angles between these two radii are bisected and they are equal. When you say something bisect, it means that the angles are shared into two equal parts. Okay? So let's call this point A and here point B. Okay, let's start with the proof given. So we have cycle centered at O and tangents AP and BP. So this is what is given to us. Construction. Okay, no, before construction, we are to prove that AP, that's the tangent AP, is equal to BP. Secondly, we are to prove that angle AOP is equal to angle BOP. The next, we are also going to prove that angle APO is equal to angle BPO. So these are the three things you are going to prove in this theorem, okay, according to the statement. And then let's start with the proof. Okay, let's start with the proof. The proof. Now consider triangle APO and triangle BPO. So we are going to consider these two triangles together, APO, this first triangle, and then the other triangle, BPO. Okay, let's proceed. So let's clean the other side of the board so that we continue with the proof. Okay, now you agree with me that angle OAP is equal to angle OBP, and that is 90 degrees, according to the first theorem, theorem 1, which says that the tangents and the radius are perpendicular, meaning that the angle between the two lines is 90 degrees. Okay, so now we have line AO, which is equal to OB, line OB, and that's the radii of the cycle. The radii of the cycle. OP is also equal to OP, which is the common side. The common side. So from this we can now clearly see that therefore triangle AOP is congruent. We are using this symbol to represent congruency, is congruent to triangle BOP. So, and the congruency is RHS. Okay, RHS. So, these two triangles, triangle OAP and OBP, are congruent triangles. So, from this deduction, we can now say that these angles, or let's say that this at first. So therefore, PAP is equal to BP, which are the tangents. Okay, and then secondly, the angle AOP is equal to angle BOP, and then finally angle APO is equal to angle BPO. Okay, so you can see now that we are able to prove these three statements. Okay, now the two sides, the two tangents are equal. From our deduction from this, if these two triangles are said to be congruent triangle, then these two sides, AP and BP, are equal. Then this particular angle at O that is bisected are equal, and angle at P that is bisected are also equal. So we've come to the end of the proof. Thank you for watching. See you next time. Bye.